Hi, myself is V. Prasad. I am studying first year MBA Sri Venkateswara College of Engineering. My topic is regression analysis. Introduction to regression analysis. Regression analysis is a powerful statistical technique used to a model to understand the relationship between variables. It helps to predict outcomes, identify influential factors, and make informed decisions based on data. Types of regressions models. Simple linear regression models in the relationship between a single predictor and a continuous outcomes variable. Multiple linear regression examines the influence of multiple predictor on a continuous outcome. Logistic regression predicts the probability of a binary outcome based on one or more predictor. Simple linear regression defining the model, establish the relationship between an independent variable x and a dependent variable y. Interpreting results, understand the strength and direction of the relationship and the statistical significance. Estimating parameters, use the method of least square to determine the slope and intercept of the regression line. Multiple linear regression accounting for multiple predictor. Understand how various independent variables influence the dependent variable. Estimating model parameters. Use a matrix and the method of least square to estimate the regression conflicts. Interpreting conflicts estimates. Understand the unique contribution of each predictor variable holding others constant. Assessing model fit. Evaluate the overall model performance using the measures like R request, R squared and statistical significance. Assumption of regression analysis. Linearity, normality, homosexuality, independence. Linearity. The relationship between predictor and the outcome should be a linear. Normality. The residuals errors should follow a normal distribution. Homosensitivity. The variance of the residuals should be constant across all levels of the predictors. Independence. The residuals should be independent of each other with no autocorrelation. Models of evaluation and diagnostics. R square measures the proportion of variance in the outcomes explained by the model. P-value determines the statistical significance of the overall models and individual predictors. Residual plots visually inspect the distribution and patterns of the residuals. Residual plots visually inspect the distribution and patterns of the residuals. Multicollinearity access the correlation between predictor variable and impact of the models. Interpreting regression results. Coefficient estimates. Understand the magnitude and direction of the relationship between predictor and the outcome. Standard errors. Evaluate the precision and uncertainty associated within the coefficient estimate. P-value and significance. Determine which predictor have a statistically significant impact the outcomes. Applications of regression analysis. Forecasting. Predict the future values or outcomes based on historical data. As well inference. Understand the relationship between variable and identify potential drivers of an outcomes. program evaluation. Assess the impact of interventions or policies on a great variable. Risk assessment. Estimate the probability of an event occurring based on the various risk factors. Limitation and consideration. Omitted variable base failure and include important predictor in the model can lead based the result. Multicollinearity. High correlation between predictor can make it difficult it is laid their individual effects. Outlier and influential points. Extreme observation can only influence the regression estimate the model fit. Non-linear relationship. Linear models may not be appropriate. The underlying relationship is non-linear. Thank you for giving opportunity.